one more way of neural like implicit representation. So implicit representation means representing a 3D scene with a continuous mathematical function. So one of the way is like signed distance function. There is another way, that is the neural implicit fields. We can make use of something called as neural implicit fields. So in neural implicit fields, we make use of neural networks to represent function. So here the function, the mathematical function will not be in the form of any formula, rather it will be a neural network itself. So the continuous mathematical function will be a neural network wherein we will be giving the coordinates, 3D coordinate x, y, z, the input coordinate to the neural network itself, and the neural network will output that okay, for that coordinate, for that point, the density, the color, the distance, it will output, and also the radiance. So the properties for that coordinate it will output. So neural network will output. And how it works is that, and see, this is actually more feasible because see, the idea is that now I'll share very good insight with you. I'll share very good insight with you. See, the idea is that for different representation, the mathematical function will change. We cannot have a single mathematical function which can represent all different 3D representation. Let us suppose in a 3D scene, I have a particular set of objects. Like I have a 3D representation, a 3D scene of a cricket match. I have a like a cricket playground. Now the mathematical representation will be very different from that of a football ground. So the problem with then so the problem is that if we go with maths, like the formula, if we go with the formula, it will be very tough for us. Why it will be tough? Because for every scene we will end up like researching and discovering that formula, mathematical formula, that okay, this is that mathematical formula which is representing this. And the easy way for that is that let neural networks learn that formula for us, and that is what neural networks are good in. They can decode the underlying mathematical function. They will learn that for us. So how we train the model? You are already aware of supervised learning. In supervised learning, what we do is that okay, this is the point and these are the properties for that point. So with this, like if we give it, if I give the neural network this information that okay, this is the point, this is the properties, this is the point, this is the property, this is the point, this is the property, and if I give millions of points along with the properties, it will learn the underlying mathematical formula. And once I have that underlying mathematical formula, I have trained a neural network which is representing a 3D scene. And the best thing about this neural network is that we can even optimize it further. Any changes in the condition, we can retrain it, we can fine tune it. Very easy, compact representation it is. So the network, it memorizes the object. To see the object, you must shoot rays through the volume and query the network at millions of points to accumulate the image. So once we have this trained neural network in place, we just have to give it the coordinates and it will give us the properties of that coordinate, and we just have to render those properties and we will create a scene we can create it. It will be time taking because neural network, every point you are passing it, it will take some time to render. It will take some time. Like in real time, we cannot generate the scene, but we can generate the 3D scene. And the best thing about this is that okay, you want to represent a new scene, you can create a new neural network, you can train a new neural network. So you can have different neural networks for different scenes. So every neural network will represent a different scene. So it can be very interesting. So that's the idea. Now the benefits of this approach: neural implicit fields, continuous resolution. So yeah, so the idea is that since so we are talking about benefits of implicit representation as whole, like it includes a neural implicit field also, signed distance field also. Since it is continuous in nature, we can zoom in, zoom out. It is memory efficient because now we don't need large memory to store information. Rather, it is stored in the form of neural networks and some mathematical functions. And it is learnable via gradient descent. So that's the idea.